and asynchronous, and we have seen the differences between a latch and flip-flops. Okay, and we have seen a basic SR latch which constructed with the help of NOR gates and NAND gates. Okay, so that is what we have seen in the last class. Now we'll see the SR latch with the control signal. Okay, so the control input. Okay, so just like enable signal, so we'll have a control input here. Control input will be like this. Right. Yeah. So just we'll see the analysis part here. So with the help of NAND gates, this will go like this. So we know the property of NAND gate, right? So NAND gate property is like two inputs X, Y, Z. It's opposite of AND gate. 0, 0. It's a 1. 0, 1. 1. 1, 0. 0. And sorry, 1. And 1, 1. It's a 0. So if one of
0
output is 1 here. Okay, so if one of the input is 0, so in case of NAND gates, the output is 1 in case of the NAND gates here. So this is the logic diagram. You can take this logic diagram. Okay, so this is a diagram using enable input. Okay, so using enable input, so we are as a SR latch. Okay, so the problem here is, what I can say about this diagram is SR latch with control input. Okay, SR latch with control input. So we'll consider the cases here. So what are different cases? The first case is we'll take the first case as S is equal to 0 and R is equal to 0 and enable is equal to, so we'll take enable as 1 first of all. Okay, and enable as 1 here. So this is the first case here. Okay, so you can check here. So see the cases here. So S is equal to, so we'll not take S is equal to 0, R is equal to 0 because they'll remain in the same state. So what I'll do, so I'll take it as S is equal to 1 and R is equal to 1. So S is equal to 0 and R is equal to 1. Yeah, sorry. Okay, so S is equal to 0 and R is equal to 1 here. So S is 0 and R is equal to 1 and enable is equal to 1 here. The enable value is equal to 1. Okay, so coming to the first, this is the first NAND gate, second NAND gate, third NAND gate and fourth NAND gate here. So coming to the first NAND gate output, so 0 and 1. So when one of the inputs of NAND gate is 0, the output is equal to 1, and here 1 and 1. So enable is 1 and the other one is 1 here, so I'll get output of 0 here. Okay, so when one of the inputs of NAND gate is equal to 0, the output of fourth NAND gate is equal to 1 here. Okay, and when this one is given to this one, this third NAND gate, so I'll get a value of 0 here. Clear?
Yes, sir.
Yes, sir.
Okay, so here I'll get a value of Q is equal to 0. Okay, so I'll get a value of Q is equal to 0 and Q bar is equal to 1. Okay, fine. So this Q is equal to 0 and Q bar is equal to 1 here. Okay, and coming to the second case, so what we'll do here is S is equal to 1 and R is equal to 0. Okay, and enable is equal to 1. Enable is equal to 1. So what happens now? So we'll check here. Okay, okay, so what happens here is, so S is equal to 1 and R is equal to 0. So when and here enable is equal to 1, right? So output of first NAND gate is 0. The output of second NAND gate is 1 here. Okay, so when one of the inputs of NAND gate is 0, so obviously the output of this NAND gate, so the output of third NAND gate is 1 here. Okay, so when this is 1, so this is given to the fourth NAND gate, so 1 1 is equal to 0 here. So what I got here, so I got a value of q is equal to 0, so q is equal to 1 and q bar is equal to 0. Okay, so earlier in the last case, what we have seen in the, I mean, when we used two NAND gates, so what we got here is we got the opposite output of this, right? So so opposite వచ్చిndi kada, so దీన్ని compare చేస్తే, so we got the opposite output. So when S is equal to 0 and R is equal to 1, and so what happened there, so Q will be equal to 1 and Q bar is equal to 0 earlier in the case of, I mean, last topic. So when we use two NAND gates, okay, when we use two NAND gates, so we got the output of Q is equal to 1 and Q bar is equal to 0. Okay, and here we got, you can check here. So when used with two NAND gates, so when S is equal to 0, R is equal to 1, Q is 1 here and Q bar is equal to 0. When S is equal to 1 and R is equal to 0, we got Q is equal to 0 and Q bar is equal to 1. But it has been, the scene has been reversed here. So here when S is equal to 0 and R is equal to 1, we got Q is equal to 0. And when S is equal to 1 and R is equal to 0, so we got Q is equal to 1. Okay, so so actually this is with the case of by addition of two NAND gates here. Okay, so NAND gates can be used as an inverter also. So the what I mean to say here is, so NAND gates can be used as an inverter. So how can we say that NAND gate are used as an inverter? You can check the truth table here. Okay, so check when two inputs are similar here. Okay, so check these two cases. When two inputs are similar, so xy is equal to 0 0 and xy is equal to 1 1. So what we got here, the output is 1 here and here the output is 0. Yes or no?
Yes, sir.
Okay, so hence the NAND gates can be used as an inverter. So hence we are getting the inverted output of the previous case here. Okay, so we are getting the inverted output of the previous case. Okay, so that is the reason here. So that is the reason for the inversion of the outputs of the previous case here. Okay, now next we can see the case. So what is the third case here? So S is equal to 0. Okay, so we'll check the values of S is equal to 0 and R is equal to 0. Okay, and enable is also equal to 1, and assume, so Q value is equal to 0 and Q bar is equal to 1 here. Okay, we'll assume these values here. Now we'll check here. So this is 0 0. Okay, and here when one of the inputs of, I mean here 0 1 and this is 1 0, so both of the outputs will be equal to 1. Okay, both of the outputs will be equal to 1. Okay, and you can check what we assumed here. So we assumed the value of Q as 0. Okay, sorry, Q as 1. We assume the value of Q as 1 and Q bar as 0 here. So 1 is given to this gate here and Q bar is given to this gate here. So this is 1 0 and this is equal to 1 1. So what is the output of 1 1? So 1 1 will be equal to 0.
0.
And what is the output of 1 0? It is equal to 1 here. Okay, so there is no change in the state when S is equal to 0 and R is equal to 0 and enable is equal to 1. Okay, so there is no change in the state here. Okay,
Excuse me, sir.
huh?
Sir, someone are waiting, sir.
Yeah. Okay, so Q is equal to 1 and Q bar is equal to 0. Clear?
Yeah, sir.
Okay, this is the case with the three cases are done, and when S is equal to 1 and R is equal to 1, so we'll get a forbidden state. So that it is evident, like when S is equal to 1, wait, S is equal to 1 and R is equal to 1 and enable is equal to 1 here. So what happens if enable is equal to 1? So both are 1s here. So what we get here? So 1 1 0 and here also it's a 0. Okay. So when one of the inputs of NAND gate is 0, so we'll get an output of Q is equal to 1, Q bar is equal to 1. So which is not possible. Clear?
Yeah, sir.
Okay. So this is 1 and this is 1 and enable is equal to 1. So when 1 1 is 0 is the output of first NAND gate, and here also 1 1. So 1 1. So 0 is the output of NAND gate 2. So when one of the inputs of NAND gate is 0, so both the outputs will be equal to 1. So Q and Q bar will be equal to 1, which is practically not possible. So hence this is a forbidden state. Okay. So S is equal to 1 and R is equal to 1. Okay. And enable is equal to 1. So it is a forbidden state. Okay, so it is called as a forbidden state there. Clear?
Yes, sir.
Yes, sir.
Next, what we can see here is, so we didn't check for enable is equal to, and enable is equal to 0. So enable is equal to 1 is fine. So we'll check for enable is equal to 0. Okay, so we'll check for enable is equal to 0 and we'll consider any input like 0, S is equal to 0 and R is equal to 1. Okay, so 0 0 it's a 1 and 0 1 it's a 1 here. Okay, so and we'll assume the previous values here. So assume, so Q is equal to 0 and Q bar is equal to 1. Okay, so when we assume Q is equal to 0, Q bar is equal to 1. So this is like, so 1 we already got here. So 1 1, so we got a 0 and here 0 1, so we'll get a 1 here. Okay, there is no
Sir,
change.
some are waiting, sir.
People will be waiting. Right. Okay.
Yes, sir.
Yeah. And yeah. So this is the case here. There is no change in the state. So when enable is equal to 0 and S is equal to 0 and R is equal to 1. So we will consider the other case. We'll change the inputs. So we'll change the inputs. 1 minute. So we'll change the inputs like S is equal to 1 and R is equal to 0 and enable is equal to 0. So what happens here? So 1 0 is a 1. So 0 0 it's a 1. Okay. So and assume Q is equal to 1 and Q bar is equal to 0. Okay, so what happens here? So 0 is given to this circuit, so I'll get a new value of 1. So 1 is given to this NAND gate here, so 1 1 I'll get a 0. So there is no change in the state. Okay, so what are the inputs I take? So what are the inputs I take? So the values of S and R, irrespective of the values of S and R. So I'll put it 1K here. So enable, if enable is equal to 0, okay, so the output that is no change state. So we'll get a no change state there. Clear?
Yes, sir.
Yes, sir.
Okay, so this will be the truth table here. Okay, so that will be the truth table. We can check here. Enable is equal to 0. The values of, irrespective of the values of S and R. Okay, irrespective of the values of S and R. So there is no change in state. And when enable is equal to 1 only, we'll check the previous cases here. Okay, we'll check the other cases here. So what are the cases here? So when enable is equal to 1, if it is a 0 0, there is no change in the state. So we know this, right? So 0 0, there is no change in state. If enable is equal to 1, if it is 0 1, so it is a reset state. So it is called as a reset state. So Q will be equal to 0 and Q bar is equal to 1. Okay, and if it is like 1 0, so it is like Q is equal to 0 and Q bar will be equal to, so Q is equal to 1 and Q bar is equal to 0. So when it is 1 1, it is an indeterminate state or forbidden state. It's not possible there. So that is a functional table. You can take that. Clear?
Yes, sir.
Yeah, sir.
Okay, so this is the SR latch with a control input. So we are using a control input in addition here. So we have seen three kinds of latches here. So we have one more latch, that is D latch. Okay, so we'll check about one more latch, that is D latch here. So done with this diagram.
Yes, sir.
Okay, so this diagram and this part and analysis part. Yeah, so next we'll see the D latch here. So take this diagram. Okay, so this D latch is used to eliminate the indeterminate state that is generated in the RS, I mean, that is SR latch. Okay, so what we got in the SR latch, so that state, indeterminate state, can be eliminated with the help of this D latch here. Okay, so D stands for data. Okay, D stands for data, or it also it can also be called as delay latch. It can also be called as delay latch. And what are the inputs we give in D latch? So that will be the output. So, but the input will be delayed here. Okay, so what are the inputs we give? So that will be the output here. So the input will be carried to the output, but with a delay here. Okay, with a delay of with a delay, will this input is carried to the output. So straight away, I can say that the next state is Q of t plus 1 is equal to D. Okay, Q of t plus 1 is equal to D here. Okay, so and if I use this enable input, so enable input, there is no change in the state. Okay, and if it is like when enable input is equal to 1, so what are the input we give here? So that will be the output. So that is the case in case of the D latch here. Okay, so we'll see the D latch here. We'll see the function of D latch. So remember these basic functions. So these are very important. Okay, so remember these basic functions. So this definitely will definitely come across these functions in the next classes and in the future classes also. Okay, so D latch here. So the first case is like, I'll consider the case of, so enable is equal to 1 only. Okay, and so D is equal to 0. Okay, so D is 0, enable is 1. Okay, this enable signal is 1 here. So this is 1 and this is 1, and we used an inverter here. So when I use an inverter, I'll get 0 each and over, so I'll get a 1 here. Okay, so what happens here? So this is D is equal to 0 and this is 1 here. So what is output of this first NAND gate? The output is equal to 1. When it is 1 1, the output is equal to 0 here. So when one of the inputs of NAND gate is a 0, the output is equal to 1 here. So this output is equal to 1 here. So when this is 1, so this 1 is given to this NAND gate. So Q will be equal to 0. Okay, so our main focus is on Q here. So when D is equal to 0, we'll get a value of Q is equal to 0. Clear? Clear or not? No
Yeah, sir.
response. Yeah. Okay, so when enable is equal to 1, and I'll say that D is equal to 1. Okay, I'll say that D is equal to 1 here. So we'll see what happens when enable is equal to 1 and D is equal to 1. Okay, so D is 1 here. Okay, so the value of D is 1, and when D is 1, this will be equal to 0. Okay, so when one of the inputs of NAND gate is 0, the output is equal to, so 1 here. When both the inputs of NAND gates are equal to 1, the output is equal to 0. Okay, so here when one of the inputs of NAND gate is 0 here, so we got a 0 here, so we are not bothered about the previous cases here. Okay, so here when one of the inputs of NAND gate is 0 here, so for third NAND gate one of the inputs is 0, so I'll get a value of Q is 1. This Q is 1 is fed to the fourth NAND gate, so 1 1 will give a 0 here. Okay, so I got Q as 1 and Q bar as 0. Okay, you can check here. So what is the value of D? That will be the value of Q here. So the value of Q is D here. D is equal to 1, and the value of D is 1, and Q is also equal to 1 when enable is equal to 1 here. Okay, so this is the data latch, and which is also called as a delay latch here. So data which is given as input is carried through the circuit and given as output here. So just a matter of delays happening here, which is also called as data latch here. Okay, so data latch here. So if I take the value of enable as 0, okay, and I'll consider the previous cases. So take the enable value as 0 here. Okay, and I'll take the value of D as 1 here. Okay, and the previous outputs are equal to 1 0 and okay, so previous outputs are is equal to 1 0 and okay, so check here. So when D is equal to 1 and enable is equal to 0, and here enable is equal to 0, and we use an inverter here, this is 0, so both the outputs are equal to 1 here. Okay, so both the outputs are equal to 1. Okay, so when both the outputs are equal to 1, so if I consider the previous cases like 1 0 here, this is given as, I mean, the previous outputs are Q is equal to 1 and Q bar is equal to 0 here. This is 1 0 and this is equal to 1 1 here. So when it is 1 0, I'll get a value of 1 here. When it is 1 1, I'll get a value of 0. So there is no change in the state here. There is no change in the state here. Okay, so truth table will be like this. So enable, so D output. Okay, so enable 0 irrespective of the value of D, the output is, there is no change in the state. Okay, so enable 1, if D is equal to 0, output is equal to 0. If enable is equal to 1, if D is equal to 1, output is equal to 1. So that will be the truth table here. Clear?
Yes, sir.
Okay, so this is the
Yes,
D
sir.
latch. So this is the D latch diagram of the D latch here. So far we discussed about D latch, SR latch with different cases, SR latch with a control input, SR latch with an AND gate, SR latch with NOR gates. Okay, and this is the D latch here. Okay, and these are the symbols used here. So generally this will be the symbols used for SR latch here. So SR latch with NAND gates is called as S-R latch here. Okay, S-R latch, because it will perform the opposite function, so hence it is called as SR latch. Okay, so that is the one which we designed with 2 NAND gates. The one which we designed with 2 NAND gates. Okay, so that is called as S-R latch. And here you can see this is the SR latch symbol here. So one is the normal output here, the other one will be the complement output. Okay, so the complement is mentioned by bubble here. Okay, the complement is mentioned by bubble, and this is a D latch here. So if you have any enable inputs, I can use enable signal also. So here D latch with enable signal, so D enable and Q1 Q bar here. Okay, so these are the signals here. So these are the symbols used for the latches here. Okay, clear?
Yes, sir.
Yes.
So next class, what we'll see here is we'll see about flip flops. Okay, we'll see about the flip flops. Okay,
Okay,
so I have
sir.
some work. So I'll let you know whether I'll be taking the class in the evening session or not. So I'm not sure, but so if not today, tomorrow. So we'll take the 2 hours class for this flip flops. Okay. So I'll be sending the recordings also. Flip flops gurinchi oka recordings unnai, oka 2 recordings laga. So I'll be sending those recordings also. So listen to those recordings also apart from this one.
Okay, sir.
Yeah. So you can leave and you can drop your attendance and you can leave.
Thank you, sir.
Thank you, sir.
Yeah, thank you and have a nice day.